Hello everyone, welcome to the Chapter 2 lab tutorial. In this presentation I'll go through the different parts of the lab as well as provide some calculation examples to help you out with some of the math. All of the detailed instructions are available on Blackboard. That is also where you will be submitting your answers. First, you'll be exploring the reasons for the seasons through an interactive online tool. Here you'll be determining the amount of daylight based on Earth's location as well as latitude, or how far north or south you are from the equator. Next, you'll have a little bit of fun with sun angles, and with this tool you will be changing the seasons and determining how sun angle influences the amount of solar radiation a location receives. The next part will involve some slightly more complicated calculations. You will actually be calculating the sun angle yourself for various locations during the winter and summer solstices. You'll be working through problem 1 in the book. Along with being in the book, the text of the problem can be found in this presentation and on Blackboard. Problem 1 states, refer to figure 2.6 and calculate the noon sun angle on June 21st and December 21st at 50 degrees north latitude, 0 degrees latitude or the equator, and 20 degrees south latitude, and then determine which of these latitudes has the greatest variation in noon sun angle between summer and winter. So, here is figure 2.6 that the book is referring to. There's even an example right there in the image over on the left. We'll actually go through that same example in just a bit. For the first example, however, we will use a location of 40 degrees north and find the noon sun angle for June 21st, or the summer solstice. We can determine from the figures in the book where the noon sun angle is 90 degrees. While figure 2.6 is great because it provides an example, the image of Earth is only for the winter solstice. So I found that figure 2.5 is also helpful as it shows all of the seasons. We'll look at the summer solstice and we can see that at that date the noon sun angle is located at 23.5 degrees north. So the first step is to find the distance in degrees between 23.5 degrees north and 40 degrees north. So all we do is take 40 minus 23.5 and we get 16.5 degrees. Next, we simply take 90 degrees minus that 16.5 degrees from above and get 73.5 degrees. And that is your noon sun angle for June 21st at 40 degrees north. The second example is the one from the book. We will keep the location the same at 40 degrees north, but we'll change the date to December 21st, or the winter solstice. To find where the noon sun angle is 90 degrees on December 21st, we can again look at figure 2.5. We see that because the northern hemisphere is tilted away from the sun now, that the noon sun angle at 90 degrees is at 23.5 degrees south latitude this time instead of north latitude. Now the steps are just like they were in the first example. So first we want to find the distance in degrees between 23.5 degrees south and 40 degrees north. So we take 40 minus a negative 23.5. The 23.5 is negative this time because it is south of the equator. So two negatives equal a positive, and 40 plus 23.5 equals 63.5 degrees. Alright, and now we just take that again, 90 degrees minus 63.5 degrees, and we get 26.5 degrees. And so that's the noon sun angle on the winter solstice for 40 degrees north. And for the last example, we'll go back to June 21st, but change our location this time to 0 degrees, or the equator. Again, we can look at figure 2.5 to get an idea of where the noon sun angle is on June 21st. Or we can just remember it from the first example. It's still 23.5 degrees north. Just as before, the first step is to find the distance in degrees between 23.5 degrees north and 0 degrees. So 23.5 minus 0 is 23.5. So that was pretty easy, right? Next, we'll take 90 minus 23.5 and get 66.5 degrees as the sun angle, noon sun angle at the equator on June 21st. So that is how you calculate sun angle. After you've calculated all of your answers, just go into Blackboard, submit all of your answers, and grading will be determined by the rubric listed in the Chapter 2 lab module. If you have any questions, please let me know either through email or through the Chapter 2 discussion forum. Have a good week.